Krish, are we live?
Yeah, I started the live, but we'll just wait till like a couple more people like start trickling in.
Let's just wait. Let's see how many viewers we have.
We won't get that many until 2. Damn it.
That's not me.
It is. It's kind of for your computer. Yeah, I started the live.
Oh, that was the other one. That's why, my bad.
Yeah, you have the So at Chat, are you going to be doing like more of a speaking presentation type thing, or is it it's like one of these interview type things?
They had them all watch my Nobel lecture, and then they're asking me questions about that.
Oh, okay, nice.
So is this your second time gonna speak at SHAD, or have you done previous ones as well?
Well, I actually, quite a few years ago now, had students work in my lab as part of SHAD. I've never spoken, but they actually work in my lab.
Nice. So what classes do you teach, or is it the only one?
Well, this one, I'm just teaching the grad course in nonlinear optics right now.
Okay, nice.
So like what classes do you normally teach, like when you have normal units going on?
You mean before the Nobel? Because I haven't taught since. I teach the 4th year lasers course. I teach 2nd year E&M, and I've taught the 1st year mechanics.
Nice.
Those are the main ones. 2nd year E&M, 1st year mechanics. Yeah.
So since then, have you been like continuing your research? Or?
Mostly I just travel the world giving the same talk. But I don't do it online because it's already on YouTube. So it's better if you just watch it on YouTube than me just speaking to a computer. I just don't think it'd be very good.
Yeah. So it's almost 2. Just 2 more minutes.
Okay.
So then that's when you can start.
Mm-hmm.
Any like quick things you should know before we start, Donna?
No.
You're good? You good?
Yeah, I'm fine.
All right. Nice. Just let these last 2 minutes drag out, and then we'll start. So we can get started now. Hello, everyone tuning in from home. Welcome to our third conversation in our virtual fireside series. In this series, we've had a very diverse and decorative panel of guests to enlighten us on their experiences in their representative fields. So in the past two fireside conversations, we've talked with a machine learning expert, Gary Huang, and an amazing teacher in our community, Mr. Saeed El-Majdani. Be sure to check those out on our channel if you guys have the chance. This series is brought to you by Youth Computing, a nonprofit youth-led organization that aims to bring emerging technology and its various applications to our community. My name is Chris Shaw, and I will be moderating alongside Nirmit to introduce our inspiring guest. Nirmit, take it away.
Hello, everyone. Today, we have invited Dr. Donna Strickland, and currently she is a professor at the University of Waterloo. Dr. Strickland is a professional in the field of laser physics. She has won a Nobel Prize award for developing a technique using laser physics. She has also been a research associate at the National Research Council of Canada. Let's give a round of applause and welcome Dr. Donna Strickland. Donna, for the rest of the audience out there, can you provide a little blurb about your research, and can you elaborate on your award-winning technique?
Yes, I like to say that I built a laser hammer. You know, sometimes it's energy that matters. If you want to destroy something, that takes energy. But, you know, like a hammer, when you try to push a nail in with all your might, it doesn't go in. You pick up a hammer and it goes in. So there are applications, there are processes that happen because of the energy or the force per unit time. And so basically what our Nobel Prize winning work was about was taking laser energy and putting it into a very short period of time. And then it acts like a laser hammer. Now, the problem is that before our project, people were trying to amplify these short pulses to give them more energy, and the laser hammer was happening inside the laser and destroying the laser as it went. And so what we figured out was a way to take the short pulse, stretch it and make it a very long pulse, amplify it safely, and then afterwards make it short. So that's what our research was about.
Awesome. And for this research, you won the Nobel Prize. So tell us about that story. How did you feel when you got the email saying you just became a Nobel laureate alongside Albert Einstein and Marie Curie?
Well, you actually get a phone call. They do call you at 11 o'clock Swedish time in the morning, which is for me in the East Coast time, 5 a.m. So it's a bit scary to get a phone call at 5 in the morning. But on the other hand, what they said to me was, please stay on the line for an important call from Sweden. And I do know that it is that week, and I do know that it is at 5 in the morning Eastern time when Sweden, you know, when the Nobel call comes in. So I was sort of hanging on to my husband going, oh my gosh, I think this is the Nobel Prize. I think this is the Nobel Prize. So it's quite exciting.
Awesome. That was really exciting. People find you as a leader in your field, but what new things have you learned from your students? As like you teach students, but like what have you learned from your students while teaching?
Well, I think you can learn a lot of things. I think I probably learned more from my grad students because, you know, you have a conversation, and this is how science is done, is that you are trying to figure out what you're looking at and what it means. And so we go back and forth. And so it's definitely an equal conversation between the student and the professor at that point, while we try to figure out what things mean. So.
And let's start talking about why. Like, why did you pursue physics as your profession as opposed to anything else?
Because I'm only good at physics and math, not much else. So it was pretty easy for me. Some people are good at a lot of things, and so they have to make a decision, but it wasn't hard for me. I didn't have to make much of a decision.
That's great. So now let's talk about what inspired your research. Like, what were the factors, the key factors that made you inspired and that sparked a feeling of awe that you wanted to do this, you want to pursue this profession, and like you want to do this research on this technique?
Well, I don't know. I mean, I know my mother used to say it was because, my mom was an educator and my dad was an engineer, electrical engineer, so it's in my blood. And they took me to the Ontario Science Centre. I was about 10 years old when it first started. I can't believe looking back now, they had a laser there. This would have been 1970. So this is not like now where you see lasers everywhere, including like a dollar store. Lasers were research entities, and yet they had one at the Science Center, and my dad said, "Oh, this is the way of the future. We have to see this." So I don't actually remember that, but that's what my mother would say sparked my interest in it. But when I was a high school student looking where to go, a nearby university, McMaster, had an engineering physics program. And I thought that sounded right up my alley because I couldn't decide between being an engineer like my dad and maybe just doing pure physics. So I walked the line. And part of their program was about lasers and electro-optics. And it was just a gut feeling that sounded really fun. And so I went and did it. And it's true, it's really fun. And I did an undergrad research project with one of the laser professors, and that turned out to be fun. So I just kept going, and it is fun.
And that journey, I can only imagine, was long and probably hard too. I mean, were there any like hardships or adversities you had to overcome?
Well, adversity is a big word. Certainly, twice during my PhD, I did seriously consider quitting. And I had to convince myself not to quit. And it wasn't just convincing. The first time, actually, I would say it was my supervisor that convinced me to stay. The second time, and I tell this story at commencement addresses, that I came back home to Guelph quite discouraged. And then I just turned on the TV, and it just happened to be the head of the Toronto's ballet school. Probably the National Ballet School. I don't know. Doesn't matter. Ballet school in Toronto. And she was saying that she tells every incoming class, if you can imagine doing anything else, go do it. Because this is too hard. You won't stay with this. And I thought, gee, every PhD student should hear that. Because it's a hard thing to get through. So then I sat there and went, what else can I imagine doing? And nothing came to mind. So I went, okay, I guess I'll go back and stick it out with grad school because that's the only thing I could see doing. So, but, the only hardship or adverse, that you talk about, I would say is that I married somebody from the same research group from grad school. And it's very hard to find two science jobs in the same city, right? And so actually our first year of marriage, we lived on opposite sides of the United States. I was in California and he was in New Jersey. And then I took a job that took me off the academic trail just so I could be in New Jersey with him. And then he followed me to Waterloo and he took himself off and took an industry job. And so it's not... We've never both had our ideal job at the same time, both living together. So that's a tough one.
Yeah. So those were some nice adversities that you were talking about. But you were talking about motivating yourself when you want to drop out of grad school, or like when you want to drop out from taking a PhD. So did you have a role model while growing up that motivated you to push through like these obstacles?
No, I have to admit, I've never been somebody who thought about role models, and I know people will ask me a lot about being a woman, and I never had a female professor, but that never made me think I shouldn't be one. So I wouldn't say that. I would say, I don't know, I think I give a lot of credit to my parents. I think my parents were the type of, first of all, I could go home to them and complain about it, but then they could also reason me out of, taking kind of rash decisions. And also I probably relied on my friends a lot. I think I had good friends in the group that helped convince me that, because the second time I was fairly far along. I think I'd already even finished doing the CPA. So it would have been foolish to not stick it out for my PhD at that point. And I think I had friends who convinced me of that. So no, I think I rely on friends that I actually know and that know me more than role models.
Wow, that's such a really interesting answer. Most people would already have like their role models in mind, but I guess you do make a great point about having like your support group is usually stronger than your role model.
Role models seem to have been coming around the last 10 years. I don't remember even hearing the word role model when I was growing up. Maybe we did, but yeah, I don't remember it even being discussed like it seems to be now.
Nice. So you already talked a little bit about this, but let's dive deeper. How did where you grew up affect your research and who you are today?
I don't know. I just had a pretty ordinary growing up experience. I think we grew middle class. My dad was an engineer. My mom, she was told. I have to say that my dad didn't want her working once they got married. Right? I mean, they were a traditional 1950s couple, and somehow my dad felt it would look like he couldn't support her if she worked. And so I think I grew up hearing this story about how this didn't seem right to my mother. She would have liked to have continued to work. I also heard my mother say over and over and over again that she wished she hadn't been talked out of taking math at university, which she was talked out of because she was a woman. And she said, I should have stuck to my guns. I would have been much better math teacher than I am an English teacher. And so I think I did grow up understanding that women before me were told what they could and couldn't do. And that she definitely did not want me to do that. Now I love the story that when I realized I was going to get married and move away from my husband. Well, actually, we weren't living together at the time either. I was in Ottawa and he was in New Jersey. And I told my parents that we were going to get married, but then live apart. My mother was horrified. She had not met Doug's family, and she thought they would think, how could I raise a daughter that would not even live with her husband? And my dad said, oh, I think it's great. And that was when she turned to him and said, really? Because I couldn't even stay married, but it's okay that your daughter's going to move right across the country for the sake of her career. And she's going, times are changing. So, I mean, that's why I said I think my parents had a lot to do with the way I see the world. And I think a lot of, what we used to call male chauvinists, along the way, I've noticed that as soon as they have daughters, and they realize that their daughters are very good, they think, oh, we can't have our ideas because they can't meet men like me with these ideas. We have to think of some other way. So, but no, I just, I think living in Canada is a great opportunity for kids. I think I've been other places now, and I think the fact that we really push public education and make sure that our public education is a good education, so that it doesn't matter where you come from, you do have access to that. And so I think that's really helped me. So I'm very grateful that I got to grow up in Canada. I'm very grateful that I had two parents that thought education was important. And, I think you can go anywhere from here.
Well, that's amazing. That's certainly a nice journey. So we talked about this a little bit, like as you were still mentioning about your perspective on how you see the world, but let's go a little bit deeper. So did you have a unique perspective that influenced your career choice or when you were growing up, or like even your work?
I don't think so. I think, I was such a shy kid, and I really loved school. And so I knew that I belonged in school. And when I heard about a Ph.D., which I didn't know what that was, and I asked, and someone told me it was like the ultimate in education, I just knew I belonged in school. So I knew from a very early age that I would get a Ph.D. While I was taking my Ph.D., people would say, what are you going to do next? And when I have no idea, my life's goal has been to get a Ph.D. And so again, I think because, I'm not athletic and I'm not artistic and I'm not, and even from a school point of view, much better at math and physics, I didn't have too much to think about, right? I just knew I belonged in school, and I was good at math and physics. And so it was very easy for me to follow that path.
And you said you were a shy kid growing up.
Very.
Now you definitely couldn't tell that you were shy because you're pretty outgoing. I mean, say so?
And this is true. And so this is, I mean, it was a decision that I made. So I always thought that probably if you asked me in high school where I was going to go, I would have said math at the University of Waterloo, because the University of Waterloo is so well known for math. And I come from very near Waterloo. But then my sister went the year ahead of me to go into engineering, and my best friend growing up, and really it was like just the two of us, was going into engineering at Waterloo. And I thought, if I go to Waterloo, I will remain sort of my, Anne's little sister. I will be, Susan's best friend. But this is no way to go through life, right? You have to push yourself a bit. And so I decided that I would not go to Waterloo. This is why, then I thought, well, I won't do math, because why would I go somewhere else to do math instead of Waterloo? And so that's when I started looking, what else can I do with my math and physics skills? And that's when I found McMaster in engineering physics. So, but it was a conscious decision at the end of high school that one should not go through life so shy as to make it stop you doing things. I would still probably say I'm a shy person. I probably still am one of those people that don't like to walk into a party, and have to try to mingle with people. But a lot of us are like that.
So a lot of people have coined the term extroverted introvert. Would you classify yourself as one of those?
I guess so. Yes.
So we've just heard about your success story, but behind those successes, like, were there any regrets that you still have, like the biggest regret in your career towards your innovation, or even like towards your works?
I don't know that I believe in regrets. No. I mean, obviously mistakes are always made, but you just keep going. And so no, I don't have regrets. I certainly have made mistakes that, maybe I had to be sorry about, but not regret. But you just keep going, you can't let your mistakes, but actually probably since just before I won the Nobel Prize was the first time I had to put in an erratum to say that work was wrong. And here's why it was wrong. And so I was actually probably feeling kind of low about that. And next thing you know, I'm winning the Nobel Prize. I'm going, oh my goodness, life is a crazy thing here. Highs and lows.
And you like kind of said already how your academics were kind of your entire goal. But now as you've aged, how would you say you maintain such a nice work-life balance, especially with such a dynamic lifestyle?
Well, when I did decide I would get married, I knew that he wanted to have children. I will say it, and my children know that I say it. I did not want to have children, right? I saw myself as a career girl. But once I decided to do it, then of course one must do it properly. So, so I actually was home except, I did take a couple of conferences a year, but most of the time I stayed home when the kids were young. And almost always we had dinner together, and I made sure of that. To the point where I also like to tell the story that, I was trying to convince my son when he was older to have Passover dinner with us because my husband and children are Jewish. And he's going, no, I'm not Jewish anymore, Mom. Don't need. And I said, I've never been Jewish in my life. And I still want to sit down. It's a time for us to sit down together as a family and have this special dinner together. And he said, Mom, if you didn't make us sit down to dinner every night, if we were a normal family and never sat down together, then this would be special. But you make us do it every night. I'm going, okay, you can't win. That's what that's the big lesson. No matter what you do, you can't win. But no, I think it is important to have a work-life balance. I'm not all about work. Although luckily my kids are old when I won this, because now I had more trouble. I was hardly ever home for the last year and a half, but my husband was able to come with me most of the time. So.
Well, so right now it's just been us asking you some questions. So now let's see what the public and what the people who are viewing this fireside conversation have to say. So here we have Dhwani Patel, who's asked, many students in high school right now don't really consider research as an appealing career, as they may see it as boring. So do you think there's a misrepresentation of what research work is like?
Why does this person think that students would think research is boring? First, I have to know why anybody would think that.
I think it's probably coming from the perspective of, especially stereotypically research, and I guess this ties into another question by Dhruv. He says that to do research, you have to be very patient and very persistent.
That's true.
So he asked, is this something you had in the beginning, or did you build the skill?
Oh, I don't know. But I agree that that's one of the things you really have to have is patience. I mean, you really only get data like 5% of the time at the best. Most of the rest of the time you're building it up and it breaks and you're falling or you go down a wrong path or anything else. On the other hand, when it works, it is so exciting to think that you're seeing something for the very first time that nobody else sees. If you figure out something and you're the first one to figure that out, that's really something, right? And so this is what the career of science is very different than a science education in a way. Because while we're teaching science, whether it's still in high school or elementary school on into undergraduate, you're always being tested on what you've learned from what other people did, and you're being tested on what you know. But science is about what you don't know. That's what being a scientist is. It's all about saying, I don't know. I don't understand why this is the way it is. And then it's just like this big giant puzzle. So I think you have to be someone who likes puzzles or, dilemmas or what have you. But that's the fun of it, is that you know that nobody knows. It's not that you don't know. Nobody knows. And so it's just like, wow, it's like being an explorer or something, right? That you just get to be the one who gets in there and tries to figure it out. How much fun can that be?
Right. So it's not really boring.
No, not at all boring. I don't know why anybody would think that.
Yeah. Another question we have, and this is more of a technical one. Maybe you can teach us a little bit more about it. But the question asks, what does the light wave IN at a quantum level? We know it isn't in the Higgs field. Do physicists even know?
I don't understand the question. What is a photon? Is that what they're asking?
They're asking about the light wave IN at a quantum level.
But I don't know what IN is. That's what I don't know.
Yeah, I don't know either. That's fine.
Sorry about that. I don't know what the question means.
Maybe, Miriam, you can clarify that in the chat. Another question that she asked, though, is what do you think about women in science? And how many female students were in your student population at the time? That probably won the Nobel Prize or before it.
Well, okay. So I was in engineering physics. Actually, my year was a pretty good year. We had 3 out of 18. So that's pretty high. And in my grad course, same thing. We had 4 out of 18. So it was one of the high years. But certainly when I would first go to conferences, there was less than 10% women always, right? I mean, there weren't very many women around. But I actually liked that. So that never bothered me. To me, I always felt like I was the special one. And I liked being special. So I was fine with that.
Yeah. And so we just got her answer from Miriam. And she was like, what medium does light wave IN at the quantum level? So she's saying light wave IN is like a light wave itself.
No. She's saying in, like, what does light wave in, what medium does light wave, I'm guessing, travel in at the quantum level?
Well, the light wave travels regardless of whether it's quantum or not, through anything, including vacuum. So an electromagnetic field, it's just part of, it's the electromagnetic field. And so it is the thing that it's always between charged particles. It is I'm trying to think of what the right word is, but yeah, I mean, anything that has to do with charged particles can produce an EM wave, and the EM wave interacts with anything that has charged particles.
Oh, okay. I see. So let's move back to the regular questions, and the chat, please feel free to keep asking questions. We love these questions, and I'm sure that you guys can get a lot more information and knowledge from asking your own questions. But we can keep moving on. What is your definition of success, and how would you measure it?
I think you're successful if you get to do something you want to do, and the people that employ you also want you to do it. I mean, what better success can you be? And so the fact that I have a job where I do want to get up and go and do it, I consider that I've been successful in finding that job. And that would be, yeah, that's the only definition for me. I mean, obviously you want to make enough money to live off of too, but but other than that, I don't think that I need a big paycheck to feel like I'm successful. I just need to know that I'm doing something that obviously is worthwhile because somebody is willing to pay me to do it, but also it's something I want to do. Not to say that my entire job is fun. There are, I don't like marking exams, horrible thing to have to do. So there's some bad things that you always have to do, but that's the price you pay to have an otherwise fun job.
So in that case, I guess we would all agree you're successful right now. So when was that time when you realized that you were successful? Like, what was the moment when?
Okay, so now you must be defining success as having won a Nobel Prize, and that would be a ridiculously high bar for anybody to say, I am successful if I win a Nobel Prize, because very few people get to do that, right? I mean, obviously, I'm the only woman alive with the prize. So, this is nothing to, and there's very few men, right? So right now, alive, there's probably, at the most 100 people that have a Nobel Prize in physics. So that's not anything to aim for. And so also I did this work in my 4th year of a PhD. So I was getting very frustrated that I was not being at all successful, right? That a lot of the roads I went down did not work out. And I had to keep trying something new and something, different and see what finally worked. So this is the very first paper I ever did in the end. And I knew that it was very successful as soon as it happened. Like even before we published the paper, I still remember the night that we saw it work. It was my colleague Steve and I together in a lab one night working, and we knew it worked. And I can still remember the excitement of that. So I knew I was successful then.
Thank you. So building on from this question is that during your journey, you've met all types of and all kinds of people. What is the most important character trait you think an individual should possess?
You mean to be a successful scientist? Well, obviously you have to be, intelligent, and you have to be curious, and you have to be patient. I think those are the 3 that you really need. I mean, if you're not curious, then you're not going to ask the question, why does this work? Or why did I see that? Or why? We've already talked about, you do need to be patient. It does take time. Science is not something that's an instant gratification thing at all. And then obviously, I think you need to have some modicum of intelligence in order to be able to solve the problems. So those would be the 3 things you really need, I think, to be a scientist.
Yeah. So do you think attitude plays a role as well? How you see the stuff in the...
Absolutely. Yes, and I'm a very positive person. I go through life always thinking it will work. I go through life thinking that people want to do the right thing. I go through life thinking that I'm on the right path. I go through life pretty much positively. And I think that helps a lot.
Yeah. So let's get a little bit more from sort of your research, and let's talk about you. What is your favorite book?
My favorite book. Well, it depends. I've thought about this because you sort of led me to believe I would be asked this. I will tell you right now, as an adult, my favorite book is Pride and Prejudice, and I will explain why. But I think I want to tell you about a story. When I was very little, I made my father read this nursery rhyme called Molly Whoopie to me. I don't know how many hundreds of times. He would say, please pick another book. And he eventually just called me Molly Whoopie, which shortened to Whoop. And for the rest of his life, he called me Whoop. So probably from the time I was 5 until he passed away in my 30s, he always called me Whoop because of this one fairy tale. And then I found it when my own daughter was young. I found it in a bookstore out in Nanaimo, BC, I think, and brought it home and read it to her because I was just so sure she would love this book. She did not love this book. But when I read it as an adult, I realized why I had loved it so as a child. And it's a story about, like so many British fairy tales, rich or poor family can't support the family. The 3 oldest girls are shoved out of the house to fend for themselves. And the 2 oldest girls are beautiful, but that's all you can say about them. Then the 3rd one, which is Molly Whoopie, she's the one with brains and spunk. And they meet a giant that's going to possibly kill them and a king with his princes. And they get offered that the oldest one can marry the first prince if they can just figure out, how to steal something from this giant. And of course, it's Molly Whoopie that saves the day. And boom, 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 the older beautiful sisters are good for nothing other than being beautiful are, given off to a prince. I think Molly Whoopie ends up with her prince too, which would be an English fairy tale. But it was a story about how using your mind and having spunk would get you through any tough situation. And so as an adult looking back at that, I went, no wonder I loved that, because I was the younger sister. You see, my daughter has no older sister, so she's not thinking this way. But I think I was the younger sister thinking, I'm Molly Whoopie. I am going to use my brains and I'm going to use my spunk and I'm going to solve the problems as I get on with life. So I think that one had a huge impact on me. So I love that book.
That's awesome. So another question would be that for our audience out there, would you be able to tell them a little bit more about what it is to win a Nobel Prize award?
What it is in the sense of, you mean just what it's like to go to Sweden and pick up the award? Is that the question?
And it would be that, and also what the Nobel Prize award is itself, because some people in our audience might not know. So would you be able to
okay. So it is amazing that the Nobel Prize is by far the most prestigious prize in science, and in the physics one is the highest in physics. And Nobel has given that sort of power to the Royal Swedish Academy of Science. And I guess at the time it had the most money, but I think it's also because he didn't want it limited to just Swedes. He said this has to be the worldwide one. This has to be the one that made the big difference. This is you have to find the scientists that impacted the world and helped humanity in some way. And so then it's been on the shoulders of the Royal Swedish Academies to figure out who these people are. And that's no easy job. And so that is why the prestige is there. It's a worldwide award, and it is supposedly somebody, that you've made a difference. So that's why it's big. I will tell you that it's a Nobel week. I don't think most people realize that. They probably think it's just one day. Somewhere around 50 or so years ago, they decided to let the royals be the ones that would give a prize. So it's really quite something. It is, I was handed the award by the King of Sweden. You get to I dined beside the King of Sweden that night. The next night we're at the palace, and I'm dining beside his son, the prince, the next night at the palace, which is really spectacular. The other thing, the one thing that's written in Nobel's will, and Nobel made his money with dynamite, and this is why he felt he should leave this money for good, because some people had used dynamite not in a good way. And so he put it in his will, though, that to accept the prize, you must give a talk about what you won the prize for, right? So you do know that when you go, you must give this lecture. It is on YouTube that everybody can now watch. So it's quite a bit of pressure to give a very good talk that has to be a public talk. It has to be a talk that anybody can follow, which is a very difficult thing to do. So that's part of Nobel Week. So there's many receptions to go to. You speak at 3 universities. I spoke at 2 high schools that week. It's a spectacular week.
And we have a lot of questions now coming in from the audience. So let's switch back to that. Okay, so here we have, has anyone said that lasers are boring to you? And if so, what did you tell them?
Why would anybody say such a thing to me? Obviously, lasers are not boring. They are beautiful colors. And, people use them as cat toys. They do so many things in this world now, from surgery to scanning your groceries at the grocery store to, having a cat toy. So at no time can anyone think lasers are boring.
And I agree. The next question is from Dhvani, and he asks, do you get any money from a Nobel Prize?
Oh, absolutely, yes. So I won a quarter of the prize. And so in my year, I brought home just a little over 300,000 Canadian dollars.
Oh. Yeah, so another question from Dhwani Patel as well is there a special group chat for Nobel Prize winners?
I don't, we're very old, so we're not into like group chatting like you younger people, okay? Like I'm one of the younger Nobel Prize winners, so no. The one thing I would say though is that there's this meeting called the Lindau Nobel Meeting that happens every year. And this is where, so every fourth year it's for physics. Then there's one for chemistry and one for medicine and physiology. And then every fourth year is for all of us to get together. So I've been to one. I was going to have gone again this year for the everybody one, but we went virtual. But last year was physics, and they had 30 some physics prize winners, Nobel Prize winners there, and something like 500 and some students from around the world. I think 80 countries were represented by students. And so that's really quite the meeting where we get to meet the other Nobel Prize winners. And then we spend a lot of time with students. It's a week-long thing. Again, I gave a talk. I had an hour question period where they were allowed to ask me anything they wanted. I didn't have to answer if I didn't want to. And they arranged for lunches with students, and we walked through a winery thing together with a different group of students, and I had dinner with a different group of students. And so you just, you compete to try to get to be one of these students who get to come. Obviously, you're considered to be a top student. The idea is that you could be a future Nobel Prize winner. And I mean, there are undergrads there, but mostly grad students and some postdocs get to come and meet us. But, and then some of the evenings, though, our hotel where the Nobel laureates are is across a lake from where all the students are. So we do have a few nights where it's just the laureates that get to know each other and spend some time together.
Awesome. Okay, so
that's how old people socialize, okay? In real.
Okay, the next question is from Kyle. Do you believe recognition is a factor of success?
I don't know. I was talking to somebody else about this. I think, the point of the Nobel isn't to tell scientists who the good scientists are. I think we sort of already know that. I mean, we do go to conferences. There are invited talks and plenary talks. And so I think there's already recognition as to who the leaders of your own personal field are. It's very hard to get known outside of your own field, though, right? Because we all read each other's papers that are in our field, and we go to the conferences that would be, so I would go to a high-intensity laser conference, so I would know who's in that field. And so I was already very well known in the high-intensity laser field, right? Now, I have to say that, again, years ago, I told my kids, if you define fame as people knowing you from around the world without ever having met you, I am famous. And my kids, who were probably teenagers at the time, going, "Oh, Mom, if you want to think you're famous, you think you're famous, but you're not really. So just know that, okay?" And then, when you win something like the Nobel Prize, what it does is shine a light so that even non-scientists for a while hear about you. And I think that's important. I think it's important because I think science literacy is important. I think people do need to understand the role scientists play in society. I think people do need to understand how the science process works so that people, now when we're in this pandemic, they understand why it would take a couple of years to get a vaccine, even though we desperately need one right now, that there are scientific procedures that have to be followed, and people will go down the wrong alley and you have to find the right one. And so I think that's what these awards really do for science, is that it makes the non-scientists stand up and, for at least for some time, take notice and say, okay, it is important that they did that work.
So that was amazing. And now we have another question, and this is from Drew Patel. He asked that most people are usually after things that are instant gratification based. What do you believe that pushed you for the long-term journey?
Well, because like I said, I just liked school. So, I mean, I suppose that's short term anyway, right? I mean, I couldn't imagine wanting to do something else. And so I was one of those really nerdy kids who at the end of summer vacation was very happy to go back to school. And so it's true that I do have to convince myself to stay at things sometimes. And so, sometimes I just go for a walk because walking calms me down. And plus it also helps me think things through quite a bit. But I'm also probably not the type of personality that needs the instant gratification like some people do. So probably an instant gratification kind of person probably shouldn't go into science because they will just be frustrated out of their mind. So.
And the next question is from Heath, and this one's kind of a funny one. Have you ever played laser tag?
No, I never have. I don't think I ever have. I've taken my son, I know where the place is in Waterloo because it's, growing up, he went there for birthday parties and stuff, but no, I never have. I mean, I wouldn't mind laser tag. I think I have more of a problem because so many people mistake lasers with lightsabers, right? Usually when I'm talking to small boys, but some girls, but definitely small boys, quite like these sabers, and those are just light bulbs, right? I have to say, no, there's nothing special about that. If the light's going out in all directions, there's no intensity. It couldn't possibly do anything. You're just swinging a light bulb around, and so maybe the electricity would hurt you or something, but it's not going to be the light. So, so I have a problem with lightsabers, but no, I mean, I suppose laser tag would be fun. I'm not a war kind of person, so I don't know that I like to, I'm not sure I was ever a tag even kind of person.
Nice. So now this question is more basically on your personal life, and it's talking about what is the daily life of a scientist like, and this is from Miriam.
This is probably the nicest thing about being a scientist is that your daily thing is quite often different from one day to the next. So it's not like we go to the same job every single day. Because of course there's the terms that I'm teaching and then you have to get ready to teach. And so you have to learn the topic and come up with the way to teach it and, mark and do all these things that are, quite different. You also do an awful lot of service for the community. So I have been president of the Optical Society. I have been on the board of the Canadian Association of Physicists. You have to usually sit on editorial boards for these publications. You have to review other people's proposals. You have to review other people's papers, right? And so these things come up. But then the very, very fun part of my day is when I get to go in the lab, if COVID is ever going to be over, I get to go in my lab and talk to my students and see what's going on. And I still get to tweak my own lasers and see if I can make something still happen. So that's the fun part too. It's just some days you get to do it and some days you don't. So yeah, your day is different all the time. And I think that's probably one of the nice things. It can also be difficult. I think when I first became a professor and realized that I had to wear all these hats and sort of multitask and keep track of, was I getting my classes ready? Was I, reviewing the papers in time? Was I going to the lab and make sure the students knew what they were doing? Was I, sitting on a board and all these things, and you had to juggle them? I found that difficult. And I will always say my favorite job was being a postdoc. As a postdoc, I suppose my life was much the same, and it's 100% research. You go in the lab and get to do nothing but research. But still, some days I would be building the laser, and some days I'd be doing an experiment, and some days things would have exploded and I would be cleaning it up, and some days we'd be writing the papers, and some days we'd just be talking about what's the next experiment. So again, it was always about the science, but it changes day after day.
And right. This next question is really related to that. You get into the lab. What is the first thing you do as soon as you step in?
Well, it's different if you're the grad student versus the supervisor. because the first thing that the grad student has to do is start turning on the laser, right? And so also just to learn that, I remember going in as a new grad student into this beautiful lab that had like a green laser pumping a red laser. It was just beautiful. I've talked about it a lot. Just to me, it was like working around a Christmas tree all year long. But there were 3 students already there, and they were just running around the room, flipping switches and tweaking knobs. And little by little, this whole laser, this whole room that, was probably 20 feet by, 20 feet, just all these many, many red and green beams came to life. And I just watched them flipping switches and tweaking knobs going, how did they learn to do that? Like, I'll never figure this out. But eventually you do figure it out, and they make you, you're afraid to even touch it because you might ruin it for the other students, but you have to get in there and do it yourself. And so it is up to the students to get in each day and turn the lasers on and start warming them up and lining them up. And this is what I said, about 90% of the stuff that goes on in my lab, it is turning the lasers on, warming them up, getting them going, to the point where you're ready to do an experiment with them, hopefully before the day's over.
Yeah, that's amazing. And we have another question from the audience, from Dhwani Patel again. And he asked, has the current pandemic situation affected any of your research?
Completely, because I'm an experimentalist. So our lab was shut down in March. So, the undergrad student project ended up not going very far. So you just sort of had to write up something from, more from just reading. My grad student is sitting there. Now, my one grad student was finished his research, so he's just writing his thesis, so he's okay. But I still think it's harder when you're not there to have, chats easier. So we're waiting to get back in the lab so we can get some experiments going.
And you must be really excited for that.
Mm-hmm.
Yeah.
But I won't be there. If we can get back in the lab, I can probably start traveling again, and then I'll just be traveling again, so I won't be in the lab anyway.
Okay, so this next question is from Heath, and I know you talked about it a little bit about your role models already, but he asked, is there another Nobel Prize winner that has amazed you or been influential to you?
Well, that's hard to say because there's probably a few, but Bill Phillips is the one that comes to mind. Because I had the opportunity, Bill Phillips came to give a talk at Waterloo. And I don't know why, but the demo person came to me and said, we've got this request for all these weird things he wants for his talk. He wants carnations, he wants liquid nitrogen, he wants a clear bowl, he wants, balloons, he wants. And I went, oh, he's giving a public talk. Of course he's giving a public talk. He's a Nobel Prize winner. Why didn't we think about that? And we ran around at the very last minute and got into the newspaper, and we got the big arts thing where people put on, productions and stuff, and had him give a public talk. And I was just amazed at what a good speaker he was. He was blowing up the balloons and putting in the liquid nitrogen to show how it would collapse because it was cold. And he just kept talking and blowing up balloons and keep putting in the same little bit of liquid nitrogen and like a magic show. And then he'd spill the liquid nitrogen on people's feet going, that's cold, isn't it? But not as cold as I'm talking about, because he won for, cooling and laser cooling. And when I heard that I won the Nobel Prize and knew, as I said, I had to give a lecture, right? You have to give a public lecture to win the prize. I thought, how do I give as good a talk as Bill Phillips? Because I was actually in Paris for the opening of the International Year of Light, and he gave a version of that talk again. And again, I marveled at how beautifully he explained laser cooling. And so he was the one, I guess, that I just kept in my mind when I kept thinking about what kind of talk I would give, because I knew I wouldn't be spilling liquid nitrogen. I asked for help from the university. I said, I can't make PowerPoint slides that will be the right kind of, I'm going to need people who can make animation things and stuff like that, which I got. I had a great creative team at Waterloo help me with that. So I would say he was the one, at least recently, that really inspired me for what I did.
That's very exciting, and that was very insightful as well. So now we have another question from the audience. This is from Miriam, and the question is, how would one become science communication slash popularizer? Or do you know anyone who is a science communicator?
Well, I've met a few because I've been interviewed by quite a few. And Joe Palca, I guess, was the last one. He's on National Public Radio in the United States. And we were both just in Chile together at a really fascinating event. So that was back in January, I guess. Seems like just the other day, because we stopped doing everything in March. And he, just realized that maybe, although he enjoyed doing science when he became as a scientist, he wasn't as driven to keep doing it. It was more the idea of reading about science and thinking about what people had done, more than having the ambition to keep asking the question why himself and answering that. And so he just got himself into journalism. But how he actually did it, I don't really know. But I think it's the fact that you start going after media type jobs. But I also think now there's enough organizations that are looking for science communicators. And again, this is because a lot of scientists realize that science literacy is important. It's important just, for us to get funded, right? So we can take a very selfish look at it and say, we are funded by taxpayers' dollars, right? And so the taxpayers have to understand that these dollars are worth spending, right? And so there needs to be this very good communication. I also think that we need to have very good communication because of these big problems like COVID or climate change. The policymakers have to be able to understand the science. But policymakers aren't necessarily people with science backgrounds. They're having to make decisions that are science-based, but they do need to be brought up to speed as in a real way from a science point of view, but not necessarily in a detailed way that the scientists need. But there is a huge need for science communication. And I think there are plenty of jobs. So either through the government or through these institutions that are trying to make sure they are talking to the government.
All right, and we only have time for a couple more questions, so we'll just go through this list, almost like rapid fire if you want.
Okay.
So the next one is also from Miriam, and she asks, what are you currently researching on before the pandemic?
Two things. Again, my research is always about trying to make novel lasers to do nonlinear optics. And so one of them, I'm trying to make, my laser is a 2-color laser, so both colors come out. I can tune the difference between them. I tune these 2 colors so that the difference is equal to a vibrational frequency of a molecule. You make that molecule vibrate, it feeds back onto the light itself. And you end up with a picket fence of colors, all separated by this vibrational frequency. So it's beautiful. You see light all the way through the entire optical spectrum. You also, on your spectrometer, sees that it goes from the infrared to the ultraviolet. So it's a beautiful thing to work on. But the idea is if you have that huge spectrum, you can make even shorter pulses than we have. And so that's the idea. I have a colleague working next door. He wants to sort of make molecular movies to watch how the energy moves in a molecule. You need a very short pulse for that. So that's what I'm working on.
That's amazing. So from Kyle Gomez, we have a question is, what changes the color of a laser?
Oh, quite a few things. So the first one that was seen is called frequency doubling. And this is the idea that before the laser came along, you always interacted one photon with one atom at a time. But once the laser came along, the field was high enough. And that means that the density of photons, right? The intensity is how intense it is how packed in are these photons. They were packed in enough that an atom could absorb 2 at one time. And when they absorbed the energy of the 2 photons, it released the energy as 1 photon, twice the energy. So it absorbed 2 red photons and sent out an ultraviolet photon. So that was the first time. That was the first way of doing it.
Awesome. And this is the last audience question. Couldn't you get a student or intern to heat up the lasers? Or is there more to it?
Can I get a student? I have undergrad students in my lab that do know how to use the laser, yes. Actually, the laser that I have now was built for us at Cornell University. And because of going across the board and we both had international grad students, it wasn't undergrad that was a Canadian undergrad that was sent down to Cornell to learn how to use the new laser down there and bring it back, and showed the grad students and me how to use the laser. So
That's very interesting and cool. So I have a question, is there anything you would like to tell young aspiring scientists to guide them in the right direction, like the future scientists that want to become one?
all I ever really say is that I think you know yourself better than anybody. So you know yourself what you find really interesting and fun. And I think you've got to go down that path, that you have to be guided by what you really want to do. You don't want other people telling you what's right and wrong. I think you have to listen to yourself.
Donna, some people are also wondering, why do you call it chirp lasers? What does chirped mean in that?
The word chirp comes from a bird's chirp, and a bird's chirp, when they sing their little notes there, the sound frequency changes in time. That's what a chirp is, where the audio frequency changes in time. And so when I said that when I had the laser hammer and we had to figure out how to stretch the pulse, we used a fiber, and in glass, red light travels faster than blue light because of what's known as dispersion. It's the same thing that makes prisms bend different colors, different amounts. And so the red light just traveled faster than the blue. And so we ended up with a pulse. We could have called it stretched pulse amplification, but we did have the pulse going from red to the blue. It was all infrared, but the reddest of the infrared to the bluest of the infrared is what we had. And so it was a chirped pulse. And so that's what we called it.
I just had a question for you. Is that basically, so like the technology, their new emerging technologies. So has that played is that a key factor in your research? Like, has that played a role in science in general, or even in your research?
Well, science is always this, is that, I wanted to do a science project. I had to invent a new laser to do it. Once there's a new laser, it showed how what we thought the science was not what the science was, and it changed the science. Once we had the new science, it could help us build even better lasers, which then, and it's this constant thing. And sometimes it's because somebody had a theory and you figure out if it's right or not. Sometimes the experimentalist just sees something they weren't expecting at all, right? A lot of people will ask me, well, why did you have to do it this way? I went, well, because it wasn't invented in 1985. Yes, I would use I would use this technology now, but you can't. So the new technologies always help, but it's always one thing driving another thing. You can't get one step without the other.
And sort of to build onto that, very specifically, how a lot of young scientists struggle with how to come up with a new idea, or trying to find a new way to solve something. So how did you do that? How did you figure out the idea of finding chirp pulses?
Well, but I was given a paper, and it was a theoretical paper about how to make high harmonics and how to make ninth harmonic or 15. So instead of the second harmonic, how to go way up there, which would require a very intense laser, not just a laser, but an intense. So this is why I was driven to make the intense laser. We didn't have one intense enough to do it. But also that was a theory paper. So I had to figure out the experiment that would make that work. And you just keep doing these things, because as you do them, you see new things and go, gee, I wonder why. And you read papers and they'll explain something and you go, gee, why does that work? Or can I make that work, or can I do it better? And it keeps going and going. And you go to conferences and you hear people talk, and something triggers you like, oh, that's almost what I'm doing, but I think about it this way. And then you have a conversation with them and see if there's a better way of looking at it, because you both are talking about it, but at it from a different angle.
Right. So it's less of making an entirely new idea out of nothing, and more building onto what you already know.
Everybody, even Einstein, is building on to what other people want to label that person did this incredible thing. And he did obviously he did an awful lot of physics, but it is always, you're just always taking one small step in a great big, road of progress. And there's always people that have done things before you, and there will be people that improve upon what you do. And you just have to take your small step. So you can't be overwhelmed like, oh, I have to be this Einstein and coming up with a whole new area of physics. No, that's usually not what's happening.
Awesome. So that seems like to be all the time we have today. As much as we would like to talk with you for as long as possible. We know you have a very, very busy schedule. Is there any final words you would like to add before we end the stream?
No, I'm just saying, if you love science, go and be a scientist. It's a great job.
Awesome.
Thank you so much.
All right, thank you.
All right, bye all.